Hi, I'm Daniel from EIM Technology, and today we're going to show you how to get started using your VEGO digital multimeter. If you're unfamiliar with what a multimeter is or what it does, it's one of the most important tools you will use in electronics because it allows you to measure all the quantities that you need to know, like voltage, current, resistance, capacitance, and many others. So when you first receive the product, when you open the box, you will find first the VEGO itself, and you'll also find a set of test probes, and you'll find another set of probes that have alligator clips, and finally you will get a thermocouple, which will allow you to measure temperature using the multimeter. So I'm going to go through and show you how to do a few basic measurements using the VEGO. So first we're going to try measuring voltage. I'm going to use the alligator clips instead of the test probes for this because I'm going to try to clip them onto components to measure them. So first thing you want to do is take your black probe and plug it into the middle station here, which is called COM. And that's always going to be the case no matter what kind of measurement you're making. You want to put the black wire into COM. And then now, because we're measuring voltage, we're going to put the red wire into this one on the right here. It's got a V on it, which means voltage, along with a bunch of other symbols. This is the port you'd use for those as well. You just want to plug that in. And now, because we want to measure voltage, we're going to turn it to, right now it's in the off state, we're going to turn it to the V. And make sure that it's on, you see on the left side it says DC. And you can also use the select button to change it to AC or to frequency if you wanted. We're going to keep it on DC because that's the kind of voltage I'm using from our DC VEGO power supply. We're going to turn this on, and I'm going to plug in this small resistor just into the positive and negative terminals. And when the alligator clips, and the red is always going to be the positive lead, which you should, unless you want to get a negative value, you should plug this into the higher potential, higher voltage. So we're going to plug that into the side that is plugged into the positive end. And then this end we're going to plug onto the side from the negative end. And you'll see we get a reading of about 4.82 volts, which is about the same as what it says is being supplied by the power supply. Next, I'll show you how to measure current. And current is tricky because when you measure current, you don't want to measure it from one end to one end in parallel like you do with voltage. You have to measure it in series, meaning that you have to make the multimeter part of the circuit so that the same current runs through it and you can measure it. So that reason, if you're using high current, or you don't know what the current is yet, you need to plug it into this port, which says, as on the left side, it says 10A. You can measure small currents with this port as well, and you'll get more precision, but you have to be sure that it is a small current. So always start here, and if it is small and you need more precision, you can switch over here and switch it to the milliamp range using the dial. So I'll show you what that looks like. So I'm using a 1 kilo ohm resistor, so this will, with the about 5 volt supply, produce a small current, but just for safety reasons, I'm going to start on this side, and I'll show you how to measure the current. So I've got this resistor running from the positive rail into a node here, and then I'm going to want to connect the supply here, and then grab a wire. And now this current is going to run from the resistor through the red lead, through the black lead, and then I'm going to connect this black lead to the ground of the power supply. So now, because I'm using this one on the left, I have to set it to the large A in amperes, and reset it there, turn on the multimeter, and you see we get a very small reading. So it's about 0.005 amps, or about 5 milliamps, which is what you'd expect. This is a 5 volt supply and a 1 kilo ohm resistor. So now that I know that it's a very small current, under 500 milliamps, it's only about 5 milliamps, I know that it's safe. And turn this off, turn everything off. It's safe for me to measure this current using this port and set it down to the milliamp range, the far right option. Now, when I turn everything on, now we're reading in milliamps. You can see it's about 4.8 milliamps, which is a little more accurate than the 0.005 we were seeing before. Now we'll show how to measure resistance. So for this, you do not want to ever measure the resistance of something while you have power. So I'll put this over here, and we're just gonna set our multimeter to this third option up, which has a little omega symbol, meaning ohms, the value of resistance. And now we're going to connect each lead to an end of the resistor, and we should get a reading which is 0.999 kilo ohms, and this is rated as a 1 kilo ohm resistor, so that's pretty accurate. Now you'll notice on your VEGO there is white text showing what the main function is, but then there are also other functions shown in the orange text within each option on the dial. And one example of that is on this one that I used for resistance. There are also 3 other symbols. They mean diode check, capacitance measurement, and continuity. I'll show continuity just for example. If you click this orange button that says select, you can change it. See, now I'm on diode check, and now you can change it to be on capacitance. Now you can change it so that we're on continuity. And for continuity, all this means is this is a way to check that 2 points are actually connected, or they have a very low resistance between them. So if I connect this to this resistor, it should not be, because these 2 points are not at the same potential. However, if I take this wire and I connect it to one end, and I connect the other end of the same wire, it'll beep because they are connected. Another feature, other than measuring electrical quantities, is actually measuring temperature. So if I take the algorithm away and we use the thermocouple that we got out of the box, and we connect the black end, as always, common port, and the red one to this same one on the right, we can now measure temperature. So whatever the temperature is at the end of this wire will be shown on the screen when we set it to where it says C and F, so Celsius and Fahrenheit readings. So right now it's set to Celsius, and we see that it's at about 29 degrees. And you can click the select button once again and change it to Fahrenheit. So now it says it's about 80 degrees Fahrenheit. So one more feature that the VEGO has, which you don't need to have any leads plugged in to do this, is the non-contact voltage feature, which you'll see in the top right here. It will NCB. This allows you to detect high voltage AC sources, such as what comes out of a wall. And so I plugged this power bar into the wall. So right now it's not doing anything. It displays EF on the screen. There's no lines, there's no beeping. But once I take the multimeter and place it close by, you'll see it begin beeping, and there are lines on the screen. When you get further away, there are fewer lines. And when you get very close to it, there will be 4 lines, and it'll begin beeping very fast to tell you that it is powered.